students, good morning all of you. So welcome to the semester algebra, abstract algebra. In this lesson we will discuss the concept of groups, subgroups, abelian groups, permutation groups, so on. The syllabus of the semester will be sent through online, so all of you look into the file, the syllabus. So today this is the first class. Let us know, so what is the group and definition of the group. Okay, let us see. Okay. Semester 4, introduction, to groups. So now we know that the universal number sets the first one is natural numbers. So all of you know the set of natural numbers is denoted by n, containing the numbers 1, 2, 3, counting numbers, so on. Number 2, integers denoted by z or capital I. So before that, okay, these integers, the set of integers containing negative numbers and positive numbers like 0 plus or minus 1 plus or minus 2. Actually, after natural numbers we have to write the whole numbers. This comes under second position, denoted by W containing 0, 1, 2, 3, so on. So the difference between natural numbers and whole numbers is only the extra 0 number is included in the whole numbers. Next, after that we have rational numbers. Rational numbers generally denoted by Q, containing all fractions like P by Q and PQ, such that PQ are taken from a set of integers and Q should not be 0. So for example, in numerical example, just like 1 by 2 and minus 3 means minus 3 by 1 and 0, 2 by 3, like that. So these are the rational numbers, and notice that the natural numbers is also rational numbers. Similarly, whole numbers and integers, all these are rational numbers. All these are belongs to Q. So the serial number 1, 2, 3 all are rational numbers also. Now we define a special type of numbers so that is irrational numbers. Irrational numbers is generally denoted by Q complement or Q dash. Irrational numbers are one second. The eraser tool is not working properly. Yes. Denoted by QC or Q complement, Q dash. The numbers which can't be expressed as P by Q, where PQ are I and Q not equal to 0. Or simply you can say the numbers which are not rational numbers, we can say those are irrational numbers. Now we go to sixth, the important set, rational numbers. Rational denoted by capital R. The rational numbers are the combination of or union of Q and Q complement. So the set of rational and irrational numbers together forms real numbers, not rational numbers, it's real numbers. Real numbers. consider the universal number sets. So let us define some properties of these sets. Properties of these sets. Yeah. The first one is closure property. Closure property. Simply consider a set, a non-empty set. Non-empty set G, that means G should contain at least one element. And for every two numbers AB belongs to G implies A plus B belongs to G. It satisfies this property, A plus B belongs to G. We say that G satisfies closure property under addition. Here place is said to be an operation on the set G. Similarly, we can take operations minus and division, multiplication, so on. So example, you take any numbers. For example, 2, 3 are taken from the natural number set. Then we are all know that 2 plus 3 is equal to 5 is also a number of the set n. So here we can say that in the set of natural numbers satisfies closure property under addition. Similarly, we can change the number set and also we can change the operation. For example, consider the operation subtraction minus. Consider the same two elements 2 3 belongs to n, but 2 minus 3 that equal to minus 1 is not an element, does not an element of n. Therefore, natural numbers n not satisfies closure property under subtraction. Under subtraction. We can write directly, note the whole numbers, integers and rational numbers. Rational numbers and a real number satisfies closure property under addition. But all these sets not satisfies closure property under subtraction. But you can say these four sets satisfies closure property under multiplication. Under multiplication. So if we consider division, so the division operation, on the division operation also these four sets does not satisfy closure property. Why? Because if we divide by 0 we get an undefined number. Therefore under the operation division, these four sets does not satisfy closure property. So next we go to associative property. Associative property. So now we discuss what is the associative property. To check associative property, we need three elements, at least three elements. So consider three elements A, consider A, B, C. A, B, C belongs to an empty set G. Then we should have A plus B plus C equal to A plus B plus C. So we should have this relation. Then we say that the set is associative under addition. Then we say that these associative under addition. number sets N and W, I, Q, R satisfies associative property under addition. So change the operation addition to multiplication. So you check the number sets whether they satisfies associative property or not. So that is your homework. So next, third property, that is existence of identity. Existence of identity. The identity concept is very interesting and also very important. If you consider any number, for example, I take a number A and Z, we should have a particular number in the Z such that A plus the number, we should have the same result A, and also the particular number plus the number A, we should have A. So obviously the number is 0. The number is 0. The number is 0. All of you know. So if the 0 belongs to the number Z, to the set Z, then we say that G has identity element. If G does not have the 0 element, then we say that there is the property of existence of identity fails. So if we consider natural numbers, natural number set, natural numbers not has the 0, the identity. Okay. If we consider integers and rationals and real numbers have additive, we say this is additive identity. 0 is the additive identity. Okay. So generally 0 is the additive identity and 1 is said to be multiplicative identity. Why? Because if you multiply 1 with any one, we get the same result. So 1 into 2, 2, like that. So next we go to fourth property, that is existence of inverse. So let there is an element A belongs to Z, then there exists an element B in G such that A plus B equal to, we should get identity element, and also B plus A is equivalent to the identity. So definitely B is minus A. Here B is B equal to minus A. So that is, we can conclude that if for every A belongs to Z, then there exists minus A belongs to Z such that A plus minus A equal to 0, A plus minus A equal to 0, and minus A plus A equal to 0. Then we say that G has inverse elements or satisfies inverse property. So these are the 4 properties. Now we define the group. So the important concept group, now we define group. Let G is a non-empty set and some dot be an operation defined on G if G satisfies the following properties. Then we say that G is a group under the operation dot. The properties are the one which are we discussed, the 4 closure property, associative, associative number 3, existence of identity, or identity property. The fourth one is inverse property or existence of inverse. If G satisfies all the four properties, we can say that G is a group, and the group G under operation dot is denoted by G dot. Then we have to mention the number set, number whatever it may be, the set and the operation combined together, we say that that is a group. So examples, let us go for examples. Z plus and Q plus R plus are groups. If I have to check the three, whether the three sets Z, Q, R satisfy all the properties or not, you have to check individually. Okay. So today we have to stop the lesson.